So I'm here with Nikku Madhusudhan, who is from the Institute of Astronomy at the University of Cambridge in the UK, at a conference called Are We a Unique Species on a Unique Planet? And it's a big question. And this morning, Nikku gave a fascinating talk on a new type of extrasolar planet here on the old campus of the University of Copenhagen in a classic auditorium, which ironically used to be the veterinary school auditorium, but has been converted into an institute of science here. And you gave a great talk on a type of planet that you hypothesize called Hycean planets. What is a Hycean planet?
So Hycean planets, these are a class of planets where the surface is covered with oceans and the atmosphere is hydrogen rich. The word Hycean comes from hydrogen and ocean.
And how does a Hycean planet differ from a normal rocky planet like our Earth?
So on Earth, the surface is, the interior is mostly rocky, and a large part of the surface is ocean, but you also have land mass. Whereas on a Hycean planet, it's just oceans, and deep oceans could be 100 kilometers or more deep, and there is no landmass to be seen. And this is a new class of planets we are proposing. It would be good targets to search for life, because they, for a given mass, they tend to be bigger than rocky planets because water is less dense than rock, and their atmospheres, being hydrogen rich, are also more observable because they will be more extended and better observed with our telescopes.
So JWST, the James Webb, has already taken spectra from one of these type planets. It's K2-18b.
That's correct.
And how far away is this planet?
So the planet is about 120 light years away.
120 light years. And you say that if life is possible on this planet, it would be seeded potentially by bioessential minerals and chemicals and compounds from asteroids and comets from within within its own solar system. Is that correct?
That is correct. So if life started on these planets, on such planets, we have found also, this was over a year ago, we showed that it is possible to maintain life through bioessential elements delivered from external sources, and the temperature and pressure in the oceans would be sufficient to sustain life for it to be habitable. So there are conditions under which this particular planet K2-18b could be habitable, but obviously we need more observations to really be sure that it is actually habitable or it is actually inhabited.
But you've already detected one potential biosignature, which is it dimethyl sulfide?
So we did not detect it robustly. We saw tentative hints of the molecule. We want to get more observations, and if more observations confirm that molecule, then that would be a big finding, but we are not sure just yet.
And so the takeaway from all this is that these are basically 9 Earth mass, but the hydrogen-rich atmospheres make them easy to detect and easy to do spectroscopy.
That is correct.
And when we say spectroscopy of the atmosphere, we are not seeing the planet directly, are we, or not? Or are we?
We are not seeing the planet directly. We are seeing the planet passing in front of the host star.
Right.
So the star's light comes through the planet's atmosphere before reaching us, the star of the host star of the planet.
Right.
And from that light, we can extract what is the atmospheric composition of this planet. So the important bit is that we detected the atmospheric composition of this planet last year, and we found multiple carbon-bearing molecules like methane and carbon dioxide, and we also know that the atmosphere is hydrogen-rich, but we did not detect ammonia, for example. And there have been theoretical papers before suggesting that if you see that composition, then that is one sign of there being an ocean on such a planet. Now, that is only a tentative hypothesis, and we want to test other hypotheses to know for sure if there is an ocean on this planet, if it is indeed habitable. But at least it's a promising sign to get us started on this path, and let's get more observations and find out.
So we're going to get more observations with the Webb telescope, and then when the European Southern Observatory's ELT, the Extremely Large Telescope, comes online later this decade, you'll be able to do follow-up observations. So this, ironically, a bizarre planet, totally unlike our own, an ocean world, but totally unlike any sort of rocky terrestrial mass planet, could offer us the first biosignatures of life on an extrasolar world.
There is the possibility. We don't know for sure, but there is the promise that it could do it. And if that is the case, then it'll tell us that we should be open to life in very diverse environments. It may be a long road to actually confirming that life is indeed on this planet, but we at least have one planet where we can keep looking.
And one of the most fascinating things about this planet is the fact that its ocean is could be 100 kilometers deep, and after you go that far down, it turns into water ice, you said.
That is correct. I mean, the internal structure of the planets are such that below the liquid water phase of liquid water, the water naturally at high pressure turns into ice. So the rocky core of the planet will be disconnected from the ocean by this thick bed of water ice. If that is indeed the actual interpretation of the data.
So thank you so much, Nikku. We look forward to hearing more about this research.
Thank you for having me here.